All right, welcome back. Good morning, good afternoon. Good talking with you. Today we're going to be dealing with growth factor and growth rate, the difference between the two. The first thing we're going to be talking about is growth, exponential growth, and we're going to do the same thing with decay. So there's two parts of today's lesson. That's a quick lesson. I'll show you a couple of examples, and then you guys could go through a bunch of practice problems on your own. So a growth factor we've talked about. A growth factor is what you see in your equation. So if you're looking at the first problem here, your growth factor is what you see in the equation. It's whatever is being raised to the x. So your growth factor is the common multiplier, as we've been talking about, in your equation. So the common multiplier, okay, of your function or equation. Okay, now this number has to be above 1 to be a growth. Okay, above 1, and that is the b value. Okay, the b value in your equation. In your equation. There we go. I'm practicing on my penmanship. All right, here we go. Get rid of the box. There we go. Good. Also, I'll get into that in a little while. So now, so we've dealt with common multipliers. It's above 1. It's the b value in your equation. Okay. Now, something you haven't heard about is a growth rate. Now, rate is always going to be a percent. Okay. It is always going to be a percent, or it's the percent of growth. It's the percent of growth. So it's the percent that it increases, or the growth, and you get that from the growth factor. Okay, so what I want you to do before you do anything is I want you to pause the video, and I want you to go through, and I want you to grab a yellow colored pencil, and I want you to color or highlight all of your growth factors in yellow. So all of your growth factors in yellow. Your growth factor is the number that's being raised to the x. Okay, so for this one, for number 3, the number that is being raised to the x is 1.4. Good. Then I want you to take a green, okay, colored pencil, and I want you to color in your initial value, or your a value, or your y-intercept, which is the other number that we're dealing with. Okay, go ahead and do that for all the practice problems on your sheet. Okay, now we're back. Now, what I want you to do, we're going to display what the growth factor is and what the growth rate is. Okay? So the growth factor is what you see in your equation. So the growth factor you already highlighted. So for number 1, y equals 2 times 1.1 raised to the x. Your growth factor is 1.1, right? Good. Now, your growth rate is something that is a little bit different. So what I want you to do is think about a scale, right? Think about a scale. Now, a scale is based off of 100%. Now, if you changed 1.1 to a percent, so if you change 1.1 to a percent, what would that be? Well, you would take your decimal and move it 2 places to the right. So what would it be? It would actually be 110%, right? So it's 110% to the right of 100% or to the left of 100%? It's actually to the right, right? Now, once you have that percentage, how much above 100% is 110%? How much above 100% is 100%? 10%? 10%. Well, it would take 10% to get there, correct? Okay, so that movement, or how much greater than 100%, is your growth rate. So 10% would be your growth rate, right? Let's try one more example. So the growth factor for number 2, y equals 144, times 1.8 raised to the x power. Okay, so your growth factor is what's in your equation. So your growth factor in this case is 1.8. Okay, now what's your growth rate? Okay, well, think of a scale. 100% in the middle. Okay, now I have 1.8. Okay, change 1.8 into a percent. Move the decimal place 2 places to the right. 1, 2. From the 0, it's 180%. Okay, then you're going to take that 180%. Is that to the right of it? To the right of 100% or to the left of 100%? It is to the right, 180%. Good. Now, how much did it take to get to 180%? How much above 100% is 180%? It's actually, the difference is 80%. So it would be 80% growth. Okay? Pause the video and go through the rest of the examples just like I did. I would want the growth factor as well as the growth rate. All right, so now that we went through a exponential growth model and talked about growth factor and growth rate, now we're going to be talking about decay factor and decay rate. Okay, so let's go back to the term. So decay factor, okay, the decay factor is your common multiplier, very similar. What's different here? This common multiplier has to be between the numbers 0 and 1, right? We know that. So it could be a decimal or a fraction between 0 and 1, okay? And this is what is in, okay? Same thing, what is in your equation. Okay? And we talk about it's the B value. B value. Okay, good. Now the decay rate is the same thing. So now it's always going to be a percent, and it is the percent of not increase but decrease or decay. Let's see if I could fix my penmanship here. The percent of decrease. Good. All right, so let's look at the first one. All right, before we do that, let's do the same thing. So let's go through, and with our yellow, let's go through and color in all of, now it's going to be our decay factors, right? Decay factors are what is inside our equation, or what's being raised to the x. And in green, let's go ahead and color our initial values. Okay, so pause the video and complete that for the rest of the practice problems. All right, now that you have all of your decay factors and initial values, or y-intercepts, color-coded, now let's talk about the decay factor versus decay rate. So the decay factor is what's inside your equation. So in this case, it's 0.1, right? Now the decay rate, now this is a little bit trickier, so just please follow along. It's very similar, so let's draw a scale, right? Now, we're always going off of 100%, right? 100, those look like 6s, sorry. So 100%. Now, we have 0.1%, right? Now, if I have 0.1, and I want to change that to a percent, how do I do that? Well, I'm going to take my decimal and still move it 2 places to the right, and that gives me what? That gives me 10%. Now, is 10% to the left of 100% or to the right? It's actually lower than, so it's always going to go to the left for decay. So 10%. Good. Now, what is the difference? How do I get from 100% to 10%? What is the difference? I mean, you could take 100 and subtract the 10, right? Or what's the difference between 10 and 100? If you're thinking 90, you're correct, right? So it's 90, a difference of 90%. So that would be our decay rate. Okay? So you're just seeing how much is in between those two numbers, right? So let's do one more. So if we have y equals 144 times 0.8 raised to the x, okay, let's talk about our decay. That's not what I wanted. Go back. Go back. Go back. Here we go. Decay factor and decay rate. Good. So our decay factor is what's inside the parentheses. So in this case, it's 0.8 is our growth factor. Okay. Now draw our scale. Think of 100%. Okay. I have my I have my growth factor as 0.8. Change that to a percent. So it's going to be 1, 2, fill in the 0, 80%, right? Now is 80% to the left or to the right? For decay, you're always going to go to the left because we're always talking about a decrease. So what is the change? What is the percent of difference there? Well, to get from 80 to 100, it is 20%. Good. Okay, so the percent of decrease here is 20%. So what I would like you to do is finish the rest of the examples. If you have any questions, please ask. See you next time.